Good morning, students. 12th English Medium Physics. Today we will start new topic, that is magnetism. Okay. Yes, we know that due to current, that is moving charges, magnetic field is produced. But in nature, there are some elements, or we can make some materials. Okay, they also produce magnetic field. They also produce magnetic field. Okay, the material which is naturally is there, it is magnet. Yes, magnet, due to magnetic field is produced, and due to that there is attractive or repulsive force on another magnet or any magnetic material. First example we will see, that is bar magnet. So what is bar magnet? We will see some properties about bar magnet. Okay, and some equations to be remembered about bar magnet. What is bar magnet? Okay, the bar magnet, it is having two poles opposite of nature. Okay, that we call one south and one north, separated by some distance, separated by some finite distance. Okay, so see, for example, yes, it is bar magnet. Suppose it is its north pole, and suppose it is its south pole. Okay, so yes, we can say it is one bar magnet, and due to this bar magnet, magnetic field is produced. Magnetic field is produced. Okay, now we will see some quantities about this bar magnet. About this bar magnet. Okay, first one is, okay, what is length of magnet? Actually, in case of bar magnet, the length is not of magnet, it is distance between two poles. Now poles, they are not actually at the ends. Okay, they are at some distance inside from the end point. Okay, so I can say it is the distance 2 lm. And yes, I can say the geometrical length, it is 2 h. So yes, effective length between two poles, it is denoted by 2 lm. And yes, you have to remember one relation, that is 2 lm is equal to, it is 5 by 6 2 h. Okay, so this first point to be remembered about magnetism. Okay, now there is one quantity, it is called pole strength. What is pole strength? It is denoted by P. It is denoted by P. Pole strength is strength of any one pole, okay, or any of pole to attract or to produce attractive force or repulsive force. So yes, pole strength is strength of each pole. Pole strength is strength of each pole, due to which it produces attractive or repulsive forces. If we say pole strength of north pole is P, then we can say pole strength of south, it is minus P. Yes, we can say. Okay, clear? They both will have the same pole strength. They both will have the same pole strength. So yes, that is one thing, that is pole strength P. Okay, for any magnet there is some pole strength. Magnet. Okay, there is one another point. Okay, this magnet, it is also called we can say it is magnetic dipole. Why it is called magnetic dipole? Dipole means two poles. Yes, one north pole and one south pole. Okay, so yes, why we call magnetic dipole? Because if we have one magnet, north pole, south pole, if we cut this magnet from this point, okay, then yes, we will have two pieces. Okay, so from at first sight you can say, yes sir, these two poles are separated. No, it is wrong. Okay, we cannot separate these two poles. If we cut magnet, then this each and every piece, yes, they behaves as magnet. If it is north pole, it will become south. It is south, and it will become north. Okay, they will behave as individual bar magnets. If we further cut this magnet, then again Poles, they are not separated. Okay, each and every piece will behave as magnet, but having some weak strength. Having some weak strength. Okay, so we cannot separate two poles. We cannot separate two poles. So we can say monopoles, magnetic monopoles. Magnetic monopoles do not exist. Do not exist. Clear? So this one point you have to remember. Okay, so that is pole strength P of magnet. Okay, if you cut its pole strength is P, its pole strength is P. Here pole strength will remain the same. So pole strength depends on which quantity? Yes, pole strength depends on cross-sectional area. Okay, it is pole strength, it depends on cross-sectional area. For example, in this case, and for example, in this case. Okay, so here as A is more, pole strength is more. In this case, as A is less, pole strength is less. Clear about this? Okay, it does not depend on length. Hello, it does not depend on length. See here in this case, it does not depend on length. Pole strength depends on cross-sectional area. Pole strength depends on cross-sectional area. Okay. Now, next point regarding that is magnetic dipole moment. What is magnetic dipole moment? Magnetic dipole moment. Okay, it is indicated by M, small m. Magnetic dipole moment is indicated by small m, and that small m is equal to it is P into 2Lm. P into 2Lm, or hello, we have exact definition that is m is equal to this P into 2Lm. But for some practical use, we can say 2Lm and 2Lg they will be equal. So you can also write here that is only 2L. 2L means length of magnet. P, that is pole strength. So yes, this equation you have to remember. This magnetic dipole moment is vector quantity. And its direction is from south pole towards north pole. Simple. So this point you have to remember. Okay, what is magnetic dipole moment? Magnetic dipole moment actually it indicates strength of magnet. Magnetic dipole moment actually indicates strength of magnet. Okay, how it produces magnetic field. So this equation, this magnetic dipole moment that you have to remember. Okay. Now see, if I have one magnet, north pole, south pole, pole strength P, its length is this. Here it is 12. Here it is 12. Or I can such a way its length is L, for example. Okay. Then what is magnetic moment of this? Then magnetic moment of this M is equal to pole strength into distance between two poles. Pole strength into distance between two poles. Now, case 1. Okay. If I cut this magnet like this in two parts. Okay, then what happens? So yes, pole strength of each pole will remain same. Length, it will become L by 2. So now what is magnetic moment of this? And this is equal to the pole strength into what is distance between two poles? It is L by 2. So I can say it is M by 2. Similarly for this magnetic moment, M dash will be M by 2. Any doubt? Okay. If I cut magnet like this, then what happens? Then yes, length remains the same, L, but this pole strength, it becomes half. Why this pole strength becomes half? Due to this reason. Okay, if area of cross section is more, pole strength is more. If area of cross section is less, pole strength will be less. So here again for each case, what is magnetic moment? M dash is equal to pole strength into length. So we can say it is M by 2. And for second, it is also M dash is equal to it is M by 2. So yes, you can remember these cases. Okay, yes, I have discussed only 2 cases. There may be possible numbers of cases. Clear about this? Okay, so yes, this basic you have to remember, so then you can easily solve some questions. Okay, then you can easily solve some questions. Now next, what is next? Yes, next we will see some equations about force and field. Okay, what is Coulomb's law in magnetism? What is Coulomb's law in magnetism? We know Coulomb's law for charges, that is F is equal to 1 upon 4 pi epsilon 0 Q1 Q2 upon R square. Here how to write? Okay, Coulomb's law in magnetism. Yes, here we will write Coulomb's law in magnetism for two poles. Okay, if you are given two poles having pole strength P1 and P2, then what is force between them? Okay, so force between two poles. Force between two poles, okay, that is Fm, magnetic force, okay, and yes, is equal to 1 upon 4 pi epsilon 0 is replaced by mu 0 upon 4 pi P1 P2 upon R square. Simple. Fm is equal to P1 1 upon 4 pi epsilon 0. Sorry. Yes, you know equation of electric field, that is 1 upon 4 pi epsilon 0 Q1 Q2 upon R square. Here 1 upon 4 pi epsilon 0 you have to replace by mu 0 upon 4 pi. Instead of charge you have to write pole strength, and R, that is distance between whatever two poles. Clear? So this first equation you have to remember. Okay, here what is Coulomb's law in magnetism? Now here in case of bar magnet, you have to remember equations of magnetic field. Okay, for example, you are given, suppose it is bar magnet, it is called its axis, it is called its equator, south pole, north pole. So magnetic moment, it is in this direction, that is N. Okay, magnetic moment, it is from south to north. Now you have to remember some equations. Okay, if pole strength of this magnet is P, if this distance is 2L, then equations of magnetic field that you have to remember. First, magnetic field on axis. B, axis is okay, so what is the equation of magnetic field on axis? P axis is equal to, it is mu 0 upon 4 pi 2n r upon under root r square minus whole square. Simple. Okay, mu 0, that is 4 pi into 10 raised to minus 7, 4 pi, that is 4 pi, 2 that is 2, and that is magnetic moment, r that is distance from center. Okay, r that is r, and l that is half of its length. Okay, if I say, if r is very greater than l, then you have to represent, you have to write l is equal to 0, then r is to 4, 1 r, then it will be on the other. Then p on axis is mu 0 upon 4 pi, here it is 2m upon r. Okay, and it is similar to 1 upon 4 pi epsilon 0 to p upon r cube, like electric dipole. Okay, so yes, from that you can also remember. Now, what is magnetic field on equator? Magnetic field on equator. So what is magnetic field on equator? Magnetic field on equator, BE, it is again mu 0 upon 4 pi. Its equation is again simple. It is mu 0 upon 4 pi. If you remember equation of electric field, then you can easily derive it. Okay, that is mu 0 upon 4 pi. It is m upon under root r square plus l square raised to 3 by 2. Okay, and again, if L is very greater than R is very greater than L, then LCO R square raised to 3 by 2, 2 cuts and it is R cube, then BE is equal to, it is mu 0 upon 4 pi, it is m upon r. It is m upon r cube. Clear? So yes, these two equations you have to remember. Okay, most of questions they are possible from these two equations. Okay, you can say if you are given a short dipole, or you can say a distance is that large distance. What is distance between B and BA? Sorry, what is relation between B and B? Magnetic field on axis and magnetic field on equator. See, mu 0 upon 4 pi, mu 0 upon 4 pi. 2m r cube. Here it is m upon r cube. So you can easily write here BA is equal to 2 B. BA is equal to, here it is 2 B. But at equal distance, okay? If you take distance is same, that is from center. Now, magnetic field on axis, we know its equation. Magnetic field on equator, we know its equation. But if you are given, suppose it is 1 point, and here you have to find what is magnetic field. Then, first of all, from center, draw one position vector r. Okay, its distance r. Magnetic dipole moment, it is in this direction, so that angle between them is theta. Then magnetic field at this point, its equation you have to remember, and it is see, magnetic field at point A. Magnetic field at point O. Ready with it? It is mu 0 m upon 4 pi r cube. Mu 0 m upon 4 pi r cube under root 3 cos square theta plus 1. So yes, it is equation of magnetic field. Okay, and yes, it is r cube actually. Okay, it is r cube. If you put value of theta in this equation, for axis it is 0. For axis it is, for axis the theta will be 0. So if you put value of cos theta, cos 0 that is 1, cos 0 that is 1. So 3 plus 1 it will be 4, and 4 square root it will be 2. So it is obviously mu 0 upon 4 pi 2m upon r cube. For equator it will be 90. So if you put cos 90 is 0. Okay, and it will be mu 0 m upon 4 pi r cube only. Clear? So if you remember this equation, you can easily rewrite these two equations also. Okay, so these basic equations, fundamental, you have to remember in all MCQs of chapter number 5, that is magnetism. Okay? Yes. Now, what is behavior of bar magnet when it is placed in magnetic field? Bar magnet in uniform magnetic field. So first, that is torque. Okay, what is equation of torque acting on bar magnet when it is placed in magnetic field? Tau is equal to it is m cross v. Tau is equal to it is m cross v. Okay, tau is equal to m cross v. Yes. What is equation of potential energy of dipole? Energy of dipole, that is U is equal to it is minus m dot v. Okay. Yes. Another equation. Your work done. Okay. What is work done? Work done to rotate dipole or this bar magnet from angle theta 1 to theta 2, that is W is equal to it is m cos theta 1 minus cos theta 1 minus it is cos theta. What is Gauss law for magnetism? What is Gauss law for magnetism? That is integration B dot ds is equal to it is 0. Yes. Integration B dot ds is equal to it is 0. That is for paramagnet. So yes, we have to remember these points. M magnetic moment, magnetic moment, magnetic moment. For paramagnet, we know that for paramagnet, we know that magnetic moment M is equal to it is P into L. That is pole strength and distance between two poles. But in case of solenoid, which also behaves as, you can say, magnet, because the solenoid, we can say it is equivalent magnet. Solenoid, we can say it is equivalent magnet. So in case of solenoid, what is magnetic moment? So yes, magnetic moment of solenoid is N-I-T. And numbers of turns, I current flowing from each turn, and A, that is cross-sectional area. Simple. So for solenoid, we have to remember this equation of magnetic moment, N is equal to N-I-A. And yes, you can use all such equations. Now if solenoid, it behaves as, it is equivalent magnet. If it is equivalent magnet, then obviously it has two poles. It has two poles. So which end behaves as which pole? Okay. For bar magnet, we know that. For bar magnet, we know that if it is south pole, it is north pole. Okay. From north pole, magnetic field outside. From south pole, magnetic field inside. Okay. And yes, it forms closed loop like this. It forms closed loop from north pole outside and in south pole inside. And in magnet, it will move from south to north. So what you have to actually remember, magnetic field outside from north pole, magnetic field south inside in south pole. Okay. So if it is on solenoid carrying some current in some direction, okay, if I observe this solenoid from this side, okay, then I will see its cross-sectional area, that is one circle like this. Okay. So yes, there are only two probabilities. The current is flowing in this clockwise direction or in this anti-clockwise direction. Yes. Okay. So how to find direction of magnetic field? Just wrap your fingers in direction of current. Just wrap your fingers in direction of current. You will see the thumb is going inside. Inside means in which pole magnetic field is going inside. In which pole magnetic field is going inside? South. This time behaves as south. Then in case, yes, we do not have to think. Okay, as we wrap fingers in direction of current outside. Yes, outside. We have discussed in chapter number 4. And from which pole magnetic field is outside? So obviously it is not. Obviously it is not. Clear? So yes, if this solenoid is equivalent to bar magnet, then it is two poles. We have to identify like this. Clear? Okay? And yes, you can use all such equations for solenoid also. Clear? Or you can also write these all equations for magnetic dipole. If you are given one magnetic dipole, then what that magnetic dipole. Okay? So yes, it is basic from chapter number 5. Now in next lecture we will see how to solve some questions. Okay?